Alright, the next subtopic, we are going to learn about turning point, maximum point, and minimum point. So this one is actually very straightforward. The only thing you have to know is that whenever the question asks you to find turning point, maximum point, and minimum point, just have to remember this. dy dx equals to 0. Why? Because just imagine this. I told you before, dy dx means what? Gradient, correct? dy dx is gradient. So you learned in the past, if the line is going upward, the tangent is going upward, it's going to be a positive gradient, correct? M equals to positive value. If the tangent is going down, it's negative value, correct? If the tangent is going horizontal, the gradient is 0. And if the line is going upward like this, vertical, gradient equals to infinity. So in other words, there are these 4 gradients that you have to understand. But since they are only asking for turning point, maximum point, and minimum point, what does that mean? Imagine you got a curve. Let's say you got a quadratic. Where's the maximum point? Here, right? At this point, how is the tangent? Flat, correct? So m is equals to 0, or dy dx equals to 0. Gradient equals to 0. Okay, that's why when you're finding maximum point, or if let's say minimum point, the gradient is always 0. Correct? And what about turning point? Turning point means, like, let's say you get a cubic graph. Okay, these are what you call as the turning points. That means the point where it turns, which is also similar to the maximum minimum point. So the gradient at these two lines, the tangent at these 2 points will be flat as well. So that's why dy dx equals to 0. So the common thing here that you have to know, whenever the question asks you about maximum point, minimum point, or turning point, or even stationary point, the gradient is always equals to 0. So these are some keywords lah. Turning point, maximum point, minimum point, or stationary point. All this is gradient equals to 0. You use this dy dx equals to 0. Okay, so that's what we are going to solve for these questions. Let's see. A wire of length 80 cm is bent to form a sector. A sector, POQ, and the center is O. So let's draw this out. You got a sector. This is P, this is O, and this is Q. It is given that OQ, so OQ is RCM, and POQ is theta radian. Okay, so they gave you in terms of radian, which is what we have also learned in the past, right? Show that the area A of the sector is this. So they ask you to prove this. Okay, so question A. How to find area of sector? We learned this in the past, right? Area equals to 1 over 2 r square theta. Correct? 1 over 2 r square theta. But if you notice in the formula here, you have 1 over 2, you have r, but you don't have theta. So what are you going to do with it? That's why you have to use the other info in the question. This question says that the wire of length 80 cm is bent to form this sector. So in other words, the perimeter is 80 cm, correct? The perimeter is 80 cm. So how do you find the perimeter? You get the r, the 2 radius plus together, plus the arc length, PQ, right? I usually go write S, okay, the arc length. So perimeter is 80 cm equals to 2r plus, so what is the arc length? Arc length is r theta, correct? So in other words, what are you going to do to substitute this into here? You have to find the theta so that you can substitute, correct? So in other words, you're going to do like this. 80 minus 2r divided by r is equals to theta. Okay, So now you can substitute this into here. So you get A equals to 1 over 2 r square. Theta is what? 80 minus 2r over r. Then here you can cut. So you get 1 over 2 r 80 minus 2r. There, shown. Correct? Same as the one that they gave you. Now the question asking you, question B, find the maximum. Maximum. So when they ask for maximum, question B here, when they ask for maximum, whenever they ask for maximum, remember you'll use dy dx, okay, equals to 0. So in this case, since they ask for the area, right, so it's not dy dx, it's dA dr. Why dA dr? Because you're differentiating the area in terms of the r value, in terms of r, okay, with respect to r. So before that, let us expand this so it becomes much easier to solve. So A equals to 1 over 2, 1 over 2 times 80 is what? 40r minus 1 over 2 times 2 is r square. So dA dr is equals to 40 minus 2r. Okay, so you have to differentiate. Okay, so now they ask to find the maximum. So what is the maximum? dA dr equals to 0, right? I told you the condition. Maximum means the gradient equals to 0. So 0 equals to 40 minus 2r. 2r equals to 40. R is equals to 20. 20 what? 20 cm. Okay, find the maximum area. Sorry, that's not the final answer. Find the maximum area. So now you know that r is equals to 20 cm, correct? So you can use it to find your area now. So A is equals to 1 over 2, r is 20 square. Theta, what is theta? You still haven't found theta yet. You have to substitute back into here to find your theta. So 80 minus 2 times 20 divided by 20 equals to theta. So theta equals to, just use your calculator. So let me do this. 20 times 2, 80 minus 40 divided by 20, answer is 2. Okay, 2 radian lah. So just multiply by 2. So you can cut here, you get 400 cm square. This is your area. Now how do you know this is maximum area? That's the key question. How do you know this is the maximum area? This one I forgot to write in the notes just now. But whenever the question asks you to find maximum or minimum, you have to prove that it is maximum or minimum. So how do you do that is by using this. You already found dA dr, right? You differentiate once. I want you to differentiate one more time. Differentiate one more time. So dA dr, okay, I'm going to write here. You're going to differentiate one more time. When you differentiate one more time, it's going to become d square A dr square. Okay, when you differentiate one more time, this is what it becomes. Okay, it's like Pokemon, you could evolve. So now is d square A dr square. So when you differentiate this, you will get negative 2. What does this mean? Okay, this is what it means. Whenever you get whatever the second derivative, right? This is the second process of differentiation. If it is more than 0, it means maximum. When it is less than 0, it means minimum. Clear? So in this case, is it more than 0 or less than 0? So it's negative 2, right? Negative 2 is less than 0. So less than 0 means maximum. Okay? So this is your, you can prove lah. You prove that it is maximum area. So that means this area is the maximum area. So this is proven. So your answer is 400. Okay? Alright, next. A piece of wire of length 240 is bent to make a shape as shown in diagram on the right. Okay, so this one here is in other words, perimeter. Because why? 240 is bent to form this shape. So this one is the perimeter. Express y in terms of x. So we just use the perimeter. So 240 equals to 13x plus y plus 24x. Sorry, before that, times 2 first. I make this times 2. Then plus 24x. So you should get 13 times 2 is 26x plus 2y plus 24x. So 240 equals to 26 plus 24, you get 50x plus 2y. So they ask you to express y in terms of x, right? So 2y equals to 240 minus 5x, sorry, 50x, y equals to, so here you can actually differentiate, right? So if I just remove 2, I will get 120 minus 25x over 2, because the 2 I'm going to bring that side, right? So I get divided by 2, so here I cut. So y equals to 120 minus 25x. Okay, so you have managed to express y in terms of x. Now next question. Show that the area enclosed by the wire is, okay, so they gave you this, as you show. Question B, how do you find the area? So there are two ways you can find. Either you cut it like this, then it becomes 2 trapezium, or you can cut like a triangle up here and rectangle down there, also can. Okay, so let's do this way lah, easier. So the area of the rectangle here is going to be 24xy, correct? So it's 24x times y, so it's 24xy. That's the first area, PQRT. Okay, let me write properly so that you all can understand. So PQRT is equals to 24x times y, so 24xy. And then now you want to find the STR. So STR, okay, so you can use 1 over 2 times base times height, or you can use the Heron formula, but I'm not going to do that. I'm just going to use 1 over 2 times base times height, much easier. 1 over 2 times base is 24x, height would be oh, you need to find height. Okay, let's see if we can use Pythagoras theorem or not. So 13x square equals to the height, okay, I'm just going to label this as h, times 12x, okay, half of this. So you're going to form this triangle. This is h, this is 13x, this is 12x. Okay, what am I writing? So h square plus 12x square. So you want to find h, right? So h equals to 13169x minus 144x square, and then square root. So you get 169 minus 144 is what? 25x square. So you get 5x. So that means the height is 5x. Okay, so the area of this triangle is going to be, is 12, so 60x square. So the area is going to be 60x square plus 24xy. But this is not the final answer. Why? Because first of all, it's not even the same, correct? It's not even the same. The reason is because in this equation here, there is no y value. There is no y value. So what we have to do is we have to substitute something into the y value so that we can try to get this answer. Okay, so what is the y value we can substitute is this. Since you already found this y equation, we can substitute to find the area. So 60x square plus 24x, y value is 120 minus 25x. So 60x square plus, So 24 times 120, you should get 280. Sorry, 2880 minus 25 times 24, you get 600 x square. Okay, so let me just write this side, no space already. So A is equals to, so 60 minus 600, you should get negative 540. But I'm going to write this first, 2880 minus 540 x square. So it is shown similar to what they wanted. Alright guys, before we continue, I just realized I missed something, which is this here. When I was expanding, I missed the value x. When I multiply 24 times 120, you should get 2880x. Okay, which I missed just now. Okay, my bad. Alright, so now let's look at the next one. Question C. They're asking for find the value of x and y for A to be maximum. So area to be maximum. So that means you need to get dA dx equals to 0 for you to find the maximum. So in this case, A is what? You already found A. 2880x minus 540 x square. So now you want dA dx, which is 2880 minus 1080x. Okay, so now it has to be 0, right? So 0 equals to 2880 minus 1080x. So 1080x equals to 2880. X is equals to 2880 divided by 1080. You should get 8/3. Okay, 8/3. What is this? cm. Okay, you can write a mixed fraction, it's fine, but I'll leave it in this. Okay, so after that, now you want to find y value, correct? And you already have the equation here, so you just have to substitute into that equation. So y is equals to 120 minus 25x. X is 8/3. So you should get your answer is 50. You can write 160/3, or you can write in mixed fraction, which is 53/1/3 cm. Okay, but I'll just leave it as maybe you can just leave it as mixed lah. It looks better. So 53/1/3 cm, and this one it can be 2/3 cm. Okay, so that is question C. Now if they want, actually you can also show that it is a maximum. How do you show? You have to differentiate one more time. Okay, if it is more than 0, it's minimum. If it's less than 0, it's maximum. So d square A dx square would be equals to negative 1080. So this is less than 0, therefore it is a maximum. Okay, so maximum area. So question C2, find the maximum area enclosed by the wire. So now they want to find the maximum area, which you have already gotten the formula here. All you have to do is substitute the x value. Okay, so I got no space anymore. I'm just going to write. Where can I write it? Okay, I'm going to erase this part. Okay, so now you want to find the area. So I'm going to write here. Question C2. C2. You want to find the maximum area. So you already know the x value for maximum area is this one here. You have already found. So you can just substitute. Okay, so 2880x, which is 8/3, minus 540 x square, which is 8/3 square. You calculate this, you should get 3840 cm square. So this should be your answer. Alright, next. A factory produces cylindrical closed containers for drinks. So you got a cylinder. It's a drink, probably canned drink. For each container has a volume. Okay, so they gave you the volume volume is 32 pi cm cube. The cost of material used to make the top and bottom, okay, so top and bottom specifically, is 2 cents per square meter, while the cost of material to make the curved surface is 2 cents per square cm. Show that the cost, okay, so that means they want you to find, question A, they want you to find the cost, correct? So since they got two pricing, you have to solve separately lah. So in this case, let us solve separately. The top layer, right? Top layer you have 2 cents per square meter, correct? Top and bottom. So let's say top and bottom cover is how you must find what's the area first. So it's pi r square, and then you have to times 2 because it's top and bottom, and then you have to times 2 cents, right? 2 cents, so you get 4 pi r square. Okay, next you want to find the curve surface. So curved surface is what? How do you find the area? So if you open this curved surface, right, you open it up, it should be a rectangle, correct? Here would be the, let's say this is the height, and then here would be 2 pi r. Why? Because it's enclosing the circle out here, so it's going to be 2 pi r. Okay, so the curved surface is going to be 2 pi r times h times 1 cent per square cm. Okay, so now question is, what is the height? That's what you don't know, because you see they ask you to prove this, right? In this equation there is no height, so that means you need to substitute the height value in terms of r, so that you can solve it. You don't have anything, but you have the volume, so you can use the volume to find out what is the height. So volume is equals to what? Pi r square h, correct? That's the volume of a cylinder. So 32 pi equals to pi r square h. So pi you can cut, so h is equals to 32 divided by r square. Okay, so I'm going to substitute into the h value here. So I should get 2 pi r h is 32 over r square. So you can simplify this. You should get 32 times 2 is 64. So it's 64 pi over r. Okay, so the cost is going to be 4 pi r square plus 64 pi over r. Shown. Is it the same? Yes, it is. 4 pi r square plus 64. Yes, correct. Now question B. Find the dimension of each container in order for the cost to be minimum. Cost to be minimum. So what does that mean? It means the cost is C, right? So dc over dr, because in terms of r. So dc dr is going to be 0. Okay, so you have already found the cost, right? C is 4 pi r square plus 64 pi r negative 1. Okay, I'm going to shift the r upward, bring it up so that it's easier for me to differentiate. So dc dr equals to 8 pi r minus 64 pi r becomes negative 2. Okay, so this one, it should be equal to 0, right? So if you rewrite this, you will get 0 equals to 8 pi r minus 64 pi r square. Now to make it easy, what I'm going to do is I'm going to take the whole equation, multiply by r square, because it's harder for me to solve with denominator. So I'm going to multiply the whole thing by r square. So I should get 0 equals to 8 pi r cube minus 64 pi. Okay, So rearrange this, 8 pi r cubed equals to 64 pi. So here you can cancel the pi. R cubed equals to 64 over 8, which is equals to 8. So r is equals to cube root of 8. Answer is 2. So it's 2 cm. Okay, so you have already found they ask for dimension, right? Find the dimension. So you need to find the r and also the height. Okay, so the r you have already found, 2 cm. Now how do you find the height? Just use back the formula here, okay, which you have already found just now. So h will be equals to 32 over 2 square. So 32 divided by 4. So 8 cm. Yeah, correct. So that will be your dimension lah. So the radius here is going to be 2 cm. Then the height is going to be 8 cm. Okay, so that's how you solve this kind of question. So we are basically done with the these two main subtopics that we are supposed to cover here: turning point, maximum point, minimum point, as well as finding the gradient and equation of tangent and the normal. Alright, so I hope you learned something from this video. If you did, don't forget to like, subscribe, and share it with someone who will also benefit from this. And I hope to see you in my next video.